So here we are doing learn recursion by building a decimal to binary converter. I recorded this the other day, but it also had some game footage to it, some me playing League of Legends, which is not cool. So we're going to do step 1 through 36 on this one, and then we'll do the next 36, and then we'll do the next 36 after that. All right, so let's get to it. Recursion is a programming concept where a function calls itself. This can reduce a complex problem into simpler subproblems until they become straightforward to solve. In this project, we're going to build a decimal to binary converter using JavaScript, and we're going to learn the fundamental concepts of recursion, explore the call stack, and build out a visual representation of the recursion process through an animation. All right, so let's get to it. Here's step 1. Let's look at this thing. So yeah, if we put in some numbers and convert it, it'll turn it into binary just like that. If we put in some negative numbers, convert it, okay, so it doesn't do negative numbers, but at least it does positive numbers, right? So let's start coding. Pardon me. So here's step 1. In this project, we're going to build a decimal and a binary converter and use and learn about both number systems. We'll also learn about recursion by using it to perform the conversions. Recursion conversions. All right. So all of the HTML and CSS for this project have been provided for us. All right. And I've already looked through this. There's nothing too crazy. We've got a media query down here, but nothing too nutty. And then here's the HTML. You can see it's basically nothing. So there's that. So when we're ready to get started, which is right now, we're going to use the getElementById method to get the input element with the ID number input and store it in a variable called number input. We're also, we're also going to do the same method for convert button and the H2 element, and we're going to call it the H2 element with the ID result, and we're going to call it convert button and result as well. All right, so let's do that. So let's say, what is the first one? Number input. So const number input equals documents dot get element by ID. Hey, you're back. Yeah, we'll do some Aurelia. We'll do some Aurelia tonight. Right now it's business time, so we're gonna have to do some learning. So yeah, document get element by ID. And we're going to say, what are we doing here? We're going to have the string, and we're going to have number hyphen input like this. Then let's slap it cap it off with a semicolon. Let's take this whole thing, copy it, and then drop it down 2 times. Should have put the const on there. Let's try that one more time, but actually doing what we want. Copy it, drop it off here, and then drop it off here. Hey, Prajwal, how's your morning going? Oh, yeah, doing well. How about you? All right, so we've got this. We're going to change the second number input. We're going to turn it to convert btn like this. And then we're going to do a result on this third one, result. We'll change the second number input. We're going to call it convert btn, convert hyphen btn, and then this one right here we're going to say result as well, result. All right, so let's check the code. Looks good, and submit it. All right, now on to step 2. So now we'll do some setup to check the value in the number input element whenever the user clicks the convert button. First, we're going to create an empty function called check user input. All right. So an empty function called check user input. We'll say const check user input. Whoa, input equals. Oh, nighttime. Well, how's your day going? There we go. So we've got check user input, and we'll what are we doing? Check the value whenever the user clicks the convert button. Okay, so let's have an empty function. We'll call it, we'll have the little empty parentheses, the arrow, and then we'll do the curly braces thusly. Let's check the code. Looks good. And submit it. All right, now on to step 3. So a good way to test that everything is working is to log the value attribute of number input into the console. As a reminder, we can access the value attribute of an element by using dot or bracket notation. Within the check user input function, we're going to use console.log to log the value of a number input to the console. All right. So we'll do console.log check user input thusly. Do we need any to log the value of number input to the console? Is that going to work? No. No. To log the value of, okay, we'll do number input dot value. Number input dot value. All right. So let's check the code. Looks good. And submit it. All right. Let's get this off the screen. Now we're on to step 4. So now that our check user input function is set up for testing, we can use an event listener to call the function when users click the convert button. All right. We'll chain the add event listener method to convert BTN. The event listener should listen for click events and take a reference to check user input function to the check user input function as a callback. Remember that function references are not called with parentheses. You got it. Once that's done, whenever we click the convert button, the value of the number input should be logged to the console. All right. So yeah. Let's see. So we're going to do the add event listener to convert BTN. All right. So let's start with that. Convert BTN dot add event listener. All right. And inside of this, we're going to do the click. Okay, we're going to do the click event, and then we will do the check user input function reference. All right. Yeah. Yeah, they do keep adding steps and sections. Did they add another one? I don't even know. If they did, I got to record that. No, they still got, it's okay. It's still the gradebook app is the newest one, but yeah, they do keep doing that. Let's check the code. Looks good and submit it. All right, now we're on to step 5. So our convert button should be working now. Well, okay. But it could get tiring for users to enter in a number and then click that button each time they want to convert from decimal to binary. Very true. It would be much more convenient to perform the conversion when the enter or return key is pressed. The key down event fires every time a user presses a key on their keyboard and is a good way to add more interactivity to input elements. We're going to change the add event listener method to number input, and the event listener should listen for the key down events and take an empty arrow function as a callback. Yep. So what we're going to do here is we'll do number input dot add event listener. Whoa. Listener. We're going to do key down, and we're going to listen for the enter key. All right. And this knows that this, when it enter, it knows it's either enter for PCs or return for Macs. I think Macs or return. I don't know. Anyway, so let's check the code. Come on now. Add event list inner. Callback function. Oh, yeah. We haven't done that yet. Okay, so let's do the callback, the empty callback function like this. And then we'll do something with the inner key in just a second. Let's check the code. Looks good and submit it. All right, now we're on to step 6. So whenever an event listener is triggered by an event object is automatically created. We don't always need to use this object. Like with our click handler above. Huh? We don't always need to use this object like with our click handler above, but it can be useful to access information about the event that was triggered. So first we're going to pass E as the parameter to our callback function, and we're going to remember that E is a common parameter name for the event object. Next, we're going to log E to the console in the body of our callback function. Okay, so let's get these parentheses, call it E, and then we'll do a console.log E inside of here. Console.log E, thusly. All right, let's check the code. Looks good, and submit it. All right, now on to step 7. So if we open our browser's console and type in the number input, we'll see event objects logged to the browser. So if we open this and this, oh, we're not seeing anything. And type in the number input. Oh, okay. Oh, we see something. Event objects logged. Oh, so these are event objects. Okay. And if we take a closer look at one of those objects, we'll see helpful properties like type and target. What? I don't think we see anything like that. But whatever. No, we don't see anything like that. Anyway, whatever. So yeah, did they add stuff to this one? Because I don't remember doing this when I did this the first time. Hey, whatever. Let's get back to it. So since we want to perform an action when the enter key is pressed, the most helpful property is key, which tells us the string value of the key was pressed. We're going to remove the console.log statement from the callback function and add an if statement that checks if e.key is equal to the string enter. We're going to leave the body of our if statement empty for now. And note, since enter and return keys have similar functions, they both have the same string value of enter. Okay, so we're going to get rid of this and do an if statement that checks e.key is equal to string enter. All right, so let's highlight this. Let's say if e.key triple equals the string, the string enter, right? Capital enter, like that. And then let's have the body of the if statement right there. So let's check the code. Looks good, and submit it. All right, now on to step 8. So next, within the body of the if statement, we're going to call the check user input function. After this, if we enter numbers into the number input and press the enter or return key, we should see numbers logged to the console. Okay. Oh man, it started thundering. Hey, if this thing, if I lose power, you know what's going on. So what we're going to do is we're going to call the check user input function. All right. And so after this, if we enter numbers into the number input and press enter, we should see the numbers logged. Okay, so let's do that. Enter. Logged. Oh, we do. Awesome. Okay, great. So let's check the code. Looks good, and submit it. All right, now on to step 9. So now that our convert button and number input are listening for clicks and enter key presses, it's time to complete the check user input function. It would be helpful to alert users if they don't enter a value into the number input, or the number that they enter is invalid. There could be, if it like even I think on Monday, the wind just started blowing a little bit, and for some reason the power went out. But yeah, it could happen. Anyway, let's get back to it. It would be helpful to alert users if they don't enter a value into the number input, or the number they enter is invalid. While the input type equals number element makes validation easier by only allowing numbers and some special characters, remember that all values we get from HTML elements are actually strings. Also, if the number input is empty, the value property will be an empty string. Okay, so anything we go into it, I know we've gone over this before, but anything that goes into an input is going to return a string whenever we access it like this. Not like this, but like with the like with these accessors, right? So inside our check user input function, we're going to use an if statement to check if the value of number input is equal to an empty string. We'll leave the body of the if statement empty for now. All right. So we'll do if, whoa. We'll say right here, if number input dot value triple equals empty string, we're going to do something. Whoa. We're going to do something. All right. So let's check the code. Looks good. And submit it. All right. Now we're on to step 10. So in an earlier project, we learned about truthy and falsy values, which are values that evaluate to true or false. I don't know if you can hear the rain raining right now, but it's raining. In JavaScript, some common falsy values we'll see are null, undefined, and number zero. Pardon me, the number zero and empty strings, right? So yeah, we know what falsy values are. Rather than check if a value is equal to a falsy value, we can use the logical not operator. So the exclamation point to check if the value itself is falsy. For example, const num equals 0. We've got console.log num triple equals 0 is true, and console.log not num is also true. Okay. What? Oh yeah, because num equals 0, this is going to be true because num is a falsy value. All right. I think if we said num, if we had num in here, without the not operator, it would give us false, but I don't know for sure. Anyway, so now we're going to update the condition in our if statement to use the logical not operator to check if number input dot value is falsy. All right. So we'll do that. We'll get this, get rid of this, and we'll just put the logical not operator in front of it like that. That should take care of it. Let's check the code. Looks good, and submit it. All right, now on to step 11. So because the input type equals number element allows special characters like period, plus, and e, users can input floats like 2.2, equations like 2e plus 3, or even just e, which we don't want to allow. So a good way to check and normalize numbers in JavaScript is to use the built-in parseInt function, okay, which converts a string into an integer or a whole number. ParseInt takes at least one argument, a string to be converted into an integer, and returns either an integer or nan, which stands for not a number. For example, we've got 2.2, we're going to get 2. 2e plus 2, we're also going to get 2. And if we get e, it's going to be nan, right? Before we get to this, I want to test something out real quick. I want to see if the number constructor. So let's do console.log. All right. And let's do parseInt e whatever. ParseInt 2e2. And let's also do comma. Let's do number constructor 2e2. 2e2. Let's see what happens. Oh, we're inside of it. Hold on. Let's get outside of the function. Let's just go here to line 14 and do that. Okay, so number constructor and this other one are going to do the same thing. Let's do the 2.2 on parseInt, and let's do number constructor 2.2. Wait, let's 2.2. All right, so number constructor is not going to get rid of the decimal points, but parseInt will. All right, so that's the difference. That's the difference. That's something I wanted to know. All right, so we're going to add a logical OR operator, so the two pipes, after the first condition in our if statement. Then we're going to pass the value's number input into the parseInt function as the second condition of our if statement. All right. So let's do that. We'll do the logical OR operator, and we'll pass the value of number input into the parse int. So we'll do number, we'll do parse int, number input inside of that. And that should take care of it. Let's check the code. Come on now. What? Oh, the value, dot value. Like that. Now let's check it. All right, looks good. And submit it. All right, now we're on to step 12. So next we need to check if the value returned by the parse int function is a number or not. To do that, we can use the isNan function. This function takes in a string or a number as an argument and returns true if it evaluates to nan. For example, isNan test will equal true because test is not a number. Isnan 2 will give us false because 2 is a number. And isNan string 3.5 is false because string 3.5 is a number. Okay. Even though it's a string of a number. Okay, turns out. So we're going to update the second condition in our if statement to use the isNan function to check if the value returned by parse int is nan. All right. The second condition of our, so we're going to wrap this thing up in parentheses. And we're going to put isNan in front of it. So isNan thusly, right? That should take care of it. Let's check the code. Come on now. All right, what is wrong here? Update the second condition in our if statement to use the isNan function to check if the value returned by parse int is nan. What was wrong with that? The value returned by parse int, so this, and then in front of that is nan. Or should I just say no, is nan? Did I write? Okay, maybe I did lowercase in earlier. I don't know. I don't remember. Anyway, check the code looks good and submit it. All right, now on to step 13. So now we can alert the user if they don't enter a number or the number is invalid before we attempt to convert it into binary. In the body of the if statement, we're going to use the alert method to display the text, please provide a decimal number, right? Note that alert is a method on the window object in the browser. So we can use either window.alert or alert. All right. So we're going to use the alert method to do this text. All right. So let's say alert. Alert like that. And then we're going to have the string, please provide a decimal number. All right. Let's come over here, convert it. Yes, we do get this. Okay, check the code. Looks good and submit it. All right, now on to step 14. So after alerting the user if the number input is empty or the value is not a number, we can use the return keyword to break out of this function early. All right. This will prevent future code in this function from running. All right. So we're going to add the return keyword after alert. Okay. So let's drop it right here. Return like that. Cap that off with a semicolon. Check the code. Looks good. And submit it. All right. Now we're on to step 15. So now we're going to start building the function to actually do the decimal to binary conversion. We'll create a function called decimal to binary with input as a parameter. We'll leave the body of the function empty for now. All right. So create a function called decimal to binary with input as a parameter. So we'll say const decimal to binary equals. We'll have input as the parameter. We'll have arrow. And then we'll have the function body like this, capped off with a semicolon. All right. So let's check the code. Looks good and submit it. All right. Now we're on to step 16. So within our check user input function, we're going to remove the console.log statement Then we'll call the decimal to binary function and pass in the value of number input as the argument. Okay, we're going to remove this, and then we're going to call this. Okay, with this as the argument. With this dot value as the argument. And also we're going to make sure to use the parseInt function to return, to convert the input into a number. Okay. So let's keep this parentheses up thing and put parseInt in front of it. ParseInt. And then let's wrap this thing in parentheses. And let's call the decimal to binary on that. So decimal to binary on that. All right. So we've got the number input dot value parseInted inside as the argument for decimal to binary. All right. So that should take care of it. Let's check the code. Looks good, and submit it. All right. Now on to step 17. So finally, we should clear the number input by setting its value to an empty string. Then later, when we convert several numbers in a row, we won't have to delete the previous number before entering the next one. Okay. So we're going to set the value property of number input to an empty string. Value property of number. Okay, that's easy. So we'll say number input dot value equals an empty string. Now, why were we doing this again? I want to reread this thing because I don't know about you, but I didn't catch what it was actually saying. So finally, we need to clear the number input by saying, oh yeah, we're clearing this thing every time we click it. That way it's fresh and it doesn't have the same number we had in it earlier. Okay, cool. So let's check the code. Looks good, and submit it. All right, on to step 18. So now that our function is set up, it's time to learn about binary numbers. So binary numbers are binary numbers are a base 2 number system. Unlike the base 10 or decimal number system we use every day that uses 10 digits, so 0 to 9, to form numbers, the binary number system only has 2 digits, 0 and 1. In computer science, these binary digits are called bits and are the smallest unit of data computers can process. For computers, 0 represents false or off, and 1 represents true or on. Okay? In our decimal to binary function, we're going to use the return keyword to return a string of the binary number representation of true. All right? Note, binary numbers can be long sequences that start with 0, so they are often represented as strings. Gotcha. Yeah, because if it was a number and it started with 0, it would get rid of the 0 when it was printed out, right? So yeah, let's do that. In this, we're going to use the return, Okay, we're going to use the return keyword, return, and then the binary representation of true, so we'll have return the string 1 capped off with a semicolon like that. So let's check the code. Looks good, and submit it. All right. Now we're on to step 19. I don't know why I always get surprised by that. It's every third one, but whatever. In the base 2 number system, the rightmost digit represents the ones place. Yeah, so this one is the ones place. This one, not those two, but this one, this one, this one, this one, and you get what I'm doing. The next digit to the left represents the 2's place, then the 4's place, then the 8's place, and so on. In this system, each digit's place value is 2 times greater than the digit to its right. So we've got the 1's, this is the 2's, the 4's, the 8's. If we had another one, it would be 16, 32, and 64, and so on. Here are the numbers 0 to 9 in the base 10 and base 2 number systems. So we got 0, which would be 0, 1, which would be 1, and then 2, which would be 0 in the 1's place, and 2 in the 1, and 1 in the 2's place. So this would be 2. So this is 3, so it's 1 in the 1's place and 2 in the 2's place. So 2 plus 1 is 3. So this is 4, which is 0 in the 1's, 0 in the 2's, and 1 in the 4, which is 4, of course. Then we got 1 in the 1, 0 in the 2, 1 in the 4, so 4 plus 1 is 5. 6 plus 2 is, 4 plus 2 is 6. 4 plus 2 plus 1 is 7. 8 plus 0 is 8. 8 plus 1 is 9. Okay, so we got that. So notice that binary numbers are formed from left to right. From the digit with the greatest place value on the left, so this one, to the least significant on the right, so this one over here, right? For example, the number 3 in binary is 11, is 1, 1, or 1 in the 2's place and 1 in the 1's place, like we just said. Then for the number 4, a digit to represent the 4's place is included on the left and set to 1. So we've got the 1 here, which is in the 4's place. And then the 2's place is 0, and in the 1's place is 0 also, like we just said. So in our decimal to binary function, we're going to convert the number 10, the decimal number 10, into binary and return it as a string. Okay, so if we've got 8 plus 1 is 9, we would need 8 plus 2 plus 0. 8 plus 0 plus 2 plus 0 to be 10, right? Of course. So 8 plus 0 plus 2 plus 0. I hope this is making sense, because this is what's going on. And that should be it. Let's check the code. Looks good. And submit it. All right, now we've got, now we're on to step 20. So bits are often grouped into an octet, which is an 8-bit set known as a byte. A byte can represent any number between 0 and 255. And since 0 is included, this is actually 256 numbers, which is, 4 times whatever. 4 times 64, 256. Okay, right? Of course. So here are the placement values for each bit in a byte. Okay. Isn't there 128 ounces in a fluid ounces in a gallon? I'm pretty sure. So we've got a half a cup, 2 cups, a quart, a half gallon, and a gallon. So, okay. If you're American. Anyway, so because bits are often grouped into bytes, it's common to see binary numbers represented in groups of 8, sometimes with leading zeros. For example, the number 52 can be represented as this. So we've got, this is 6 numbers. So 1, 2, 3, 4, 5, 6. So this is starting at 32 plus 16 plus 0 plus 4 plus 0 plus 0, right? So 32 plus 16 plus 4. 32 plus 16 is 48, plus 4 is 52, right? Right. All right. So if it had leading zeros, it would have this one, this 0, and this 0 as well. Okay. So here's how that breaks down with the placement value. So we've got 128, 64, 32, 32 plus 16 plus 0, plus 4 plus 0 plus 0. So 0 plus 0 plus 32 plus 16 plus 0 plus 4 plus 0 plus 0. All right. So in our decimal to binary function, we're going to convert the number 118 into binary with leading zeros and return it as a string. Okay. So let's get rid of all this. We're going to have leading zeros. Okay. So 118 is less than 128. So we're going to start off with a 0 for sure. 118 is going to have a 1 in the 64's place. So 118 minus 64. Let's get the calculator out. 118 minus 64 equals. So we're going to have 54 left. So 32 will definitely work. So let's put the 32 there. Let's get the calculator back up. So let's subtract 32. So we've got 22, which 16 will definitely fit there. So let's put a 1 there. Let's get that and subtract 16. So we've got 6. So 8's not going to work. So let's put a 0 there because 8 is bigger than 6. 8 is not bigger than 4, so we're going to have a 1 there. And then it's going to be 6 minus 4, which is 2, which is another 1. And then we're going to have a 0 because we don't have anything in the ones place. Okay, cool. So that should be what it is. And that's basically how you do. You just subtract whatever place from the number we're going for. Hopefully that makes sense for you. So let's check the code. Looks good. And submit it. All right, now on to step 21. So now that we're familiar with binary numbers, it's time to finish building the function to do the conversion for us. We're going to start off with a simpler solution first. Then we'll refactor that into a recursive solution, okay? First, we're going to need to create some arrays to store the inputs, and results of the division we'll do in the following steps. These will make it easier to see how the decimal to binary conversion works. All right. So we're going to remove the return statement from our decimal to binary function. Then we'll declare variables named inputs, quotients, and remainders, and we'll assign an empty array to each of them. Okay. So we're going to remove this to start. So let's highlight that. Then we're going to declare variables named inputs, quotients, and remainders, and we'll give them all empty arrays. So we'll say const inputs equal empty array. Let's cap that off with a semicolon. Let's get this from 6 to the end of 5. Copy that. No. Copy that. Drop it off 1, 2 times. We'll change the second inputs to quotients. We'll change the third one to remainders. All right, so that should take care of it. Let's check the code. Looks good, and submit it. All right, now we're on to step 22. So now we're going to set input equal to the number 0 for now. We'll change this in the next few steps. You got it. Input. Okay, input is the argument. Okay, so we'll change that to 0. Input equals 0. Got that off with a semicolon. Check the code. Looks good, and submit it. All right, now we're on to step 23. So for the decimal to binary conversion, we need to divide input by 2 until the quotient, or the result of dividing two numbers, is 0. But since we don't know how many times we need to divide input by 0, we can use a while loop to run a block of code as long as input is greater than 0 and can be divided. So as a reminder, a while loop is used to run a block of code as long as the condition evaluates to true, and the condition is checked before the code block is executed. For example, if we let I equal 0 and we say, well, 5 is less than or equal to 5, we'll do console.log I, and then we'll also say I++. So it's going to log 0, then do an I++, then a log 1, I++, 2, ++3, ++4, and then it checks it in 5 is not less than 5. So it won't run on that last one, and we'll have 0, 1, 2, 3, 4 in the console. All right. So we're going to create a while loop that runs as long as input is greater than 0. And we'll leave the body of the loop empty for now. Okay. So let's do that. We'll say while input is greater than 0, and we'll have the code like that. So let's check the code. Come on now. Greater than 0. Yeah, of course. Greater than 0. Greater than 0. All right, let's check the code. Looks good, and submit it. All right, now we're on to step 24. So the tricky part about while loops is that if we're not careful, they can run forever. Very true. This is called an infinite loop and can cause our browser to crash. To avoid infinite loops, we need to make sure that the condition for the while loop eventually becomes false. In this case, we'll want to make sure that the input variable eventually becomes 0. We're going to move the input equals 0 statement into the body of the while loop. This will make it so that the loop will only run up to one time. Okay, so we'll take this, we'll do a Control X on it, and then we'll I guess we'll bring this up 2 times. And then we'll do a control V inside of here. And let's tab this over while we're at it. So let's check the code. Looks good. And submit it. All right. Now we're on to step 25. So to divide numbers in JavaScript, we're going to use the division operator, so the slash. For example, we've got const quotient equals 5/2, which equals 2.5. In the example above, 5 is the dividend, so we got the dividend here, and or the number to be divided, and 2 is the divisor, so this is the divisor right here, or the number to divide by. The result 2.5 is called the quotient, so this is the quotient right here. All right. So inside our while loop, we're going to create a variable named quotient and assign it the value of input divided by 2. Right. So we'll say const quotient equals input divided by 2. Cap that off with a semicolon, check the code, looks good, and submit it. All right, now on to step 26. So like we saw in the last step, division can lead to a floating point number or a number with a decimal point. Yes. The best way to handle this is to round down to the nearest whole number. So we're going to use the math.floor function to round down the quotient of input divided by 2 before it's assigned to quotient. Yeah. I don't know if we've gone over math.floor, but this is definitely the way to round down if we need to round down, which we will in a lot of cases. So let's wrap this thing in parentheses. We'll do math.floor in front of it. Check the code. Looks good. And submit it. All right, now on to step 27. So now that we have an operation that will lower the value of input each time the loop runs, we don't have to worry about the loop running forever, right? So we're going to update the last line of our while loop and assign quotient to input. Okay. Assign quotient to input. Okay, so we'll put quotient right here instead of 0. So we'll say quotient like that. Okay. So let's check the code. Looks good. And submit it. All right. Now we're on to step 28. So next we're going to need to evaluate the remainder of input divided by 2. We can do this by using the remainder operator. So the percent sum, which returns the remainder of the division of 2 numbers. So for example, const remainder 5 remainder operator 2 is going to be 1 because 5 divided by 2 is going to be 2 remainder 1. Remember how I should open paint for this. Paint. Let's do paint. There we go. So remember in math when we were little kids, we would do something like this, like 5 that's like a square root thing. 5, 2, and then we would say, okay, this goes in it 2 times. 2 times 2 is 4. Subtract that, remainder 1, and then we'd say 1 goes in that 0, and then we would say bring down the 0. 1 goes into thing 5 times, 10 5 times, but we don't want this part. We just want this part. There we go. That's the remainder. No. All right. So where are we? So in other words, the dividend 5 can be divided by the divisor 2 multiple times. Then we're left with a remainder of 1. Okay. So inside our while loop, we'll create a variable named remainder and use the remainder operator to assign it the remainder of input divided by 2. Okay. Let's do that. So we'll say right here, const remainder equals, and then we'll say input remainder operator 2. And the remainder operator is shift 5. So that should take care of it. Let's check the code. Looks good. And submit it. All right, now we're on to step 29. So inside our while loop, we're going to use the push method to append input to the inputs array. This will help us get a better idea of how the conversion works later when we log the contents of our arrays to the console. Okay, inside the while loop, we'll use the push method to append input to inputs. Okay, so we're pushing what? Input. So yeah, what? Oh, we're pushing whatever the input is after we do this stuff to inputs. No, not even after it. We're just going to push whatever the input is into inputs. Okay, so yeah, we'll say inputs dot push, and then we'll push in input. All right, so that should take care of it. Let's check the code. Looks good, and submit it. All right, now we're on to step 30. So now we're going to use the push method to append the quotient variable to the quotients array. Also, we'll append the remainder variable to the remainders array. Okay, so we're going to do the same thing for these two things right here. Yeah, let's just take 14 to the end of 13, copy it, drop it off 2 times. We'll change inputs. Actually, look, let's change input to quote, this input inside the parentheses to quotient, and this one to remainder. Let's double click quotient, highlight everything before the S on inputs, drop it. Double click remainder, highlight everything before the S on inputs, drop it, and that should take care of business. Let's check the code. Looks good, and submit it. All right, now we're on to step 31. So now is a good time to check our work. We're going to log the text inputs, space, followed by a comma, followed by the inputs array into the console. Okay, let's do console.log. We'll have the string inputs, space, and then we'll have comma, inputs like that. Let's open up the console. Blah, blah, blah. Let's put some numbers in there. Blah, blah, blah. Convert. Okay, so there we go. That's everything divided by 2. Is that what we're doing? Yeah, everything divided by 2 and then math.floored all the way down to 1. Dang, I picked a number they put all odd numbers in there. No, we got 2 evens right here. And then another one. Okay, it doesn't matter. All right, check the code. Looks good. And submit it. All right, now we're on to step 32. So next we're going to log the text quotients followed by a comma and then do the same thing to remainders. Okay, so let's take all of 20 to the end of, all of 19, it doesn't matter. Let's take that, drop it off 1, 2 times. Bring this back. Let's change inputs to quotients. Quotients. And then we'll do remainders. And then let's do quotient here, remainders here. Check the code. Nope. What did I do? Quotients. Is that not how it's spelled? Quotients. Remainders. Okay. Check the code. Looks good. And let's check it over here too. Beep, beep, beep. Convert console. Inputs. Quotients. Remainders. Gotcha. Submit it. All right, now on to step 33. So now if we enter in the number 6 and click the convert button, we'll see the following output. Inputs this, quotients this, and remainders this. And we can notice the remainders array is the binary representation of the number 6, but in reverse order. Yes. This would be the 1's place, which is 0. This would be the 2's, which would be 2. And this would be 4's, which would be 4. So 4 plus 2 is 6. True. So we're going to use the reverse method to reverse the order of the remainders array. And join and the join method with an empty string as a separator to join the elements into a binary number string. Then we'll set result.innerText equal to the binary numbers string. Okay. So what we'll do here is say remainders dot reverse dot join with an empty string, and we're going to set this to text remainders dot result dot inner text. Should have did that first, but whatever. Result dot inner text equals that. Cap that off with a semicolon. Let's actually test it. Let's put 6. Why not? Convert it. 110. All right, great. Check it. Looks good, and submit it. All right, now we're on to step 34. So our decimal to binary function works well, but there is an issue because of the condition in our while loop. It only works for numbers greater than 0. True. If we try to convert 0 to binary, nothing will get added to the page. So to fix this, we're going to add an if statement to check if input is equal to 0, and we'll leave the body of the if statement empty for now. Okay. So we're going to do an if statement. If input triple equals 0, we're going to do something. All right. So let's check the code. Looks good, and submit it. All right, now we're on to step 35. So within the body of the if statement, we're going to set the inner text property of result equal to the string 0. Then we'll use an early return statement to break out of the function early. Okay. So we're going to set inner text property of result. So result.innerText is going to equal the string 0. Then we'll do a return statement. Okay. So result.innerText equals string 0. Cap that off with a semicolon. Come down here, return early, semicolon, check the code, looks good, and submit it. All right, now we're on to step 36. So now our decimal to binary function is complete. We can feel free to play around with it. Okay, let's try 0. Convert. 0, yay. How about 10? 1010. 1010, yay. Okay, great. But there are some ways to improve it. For example, it's not necessary to keep track of the inputs and quotients. We can clean things up so the function is more efficient. Pardon me. So first, we're going to remove everything in the body of the decimal to binary function, then use let to create a variable named binary and assign it an empty string. Oh, bye-bye code. Is this all of it? Bye-bye code. Let binary and assign it an empty string. All that work just for this. All right, so let's check the code. Looks good, and submit it. All right, so now we're on to step 37, but I'm going to take a break because it's good to break this thing down into 3 parts. So I'll go live later. I don't know, maybe 20 minutes, maybe 30 minutes, who knows. And we'll start at step 37. Let's take a break, get some water, do some exercise, do some taxes, whatever we got to do. Oh, I should have had this open. Act like this part's not happening. Act like this part's not happening. Act like I'm not doing this right now. Pretend that you can't see this. Actually, I'll do this. Oh, you already saw it. Let's get rid of that. Now okay, so now at 37, we're going to take a break, do your taxes, whatever. And we'll see you next time. Wait, how about there? All right, awesome. Oh wait, I still gotta push stop. It's not like the same when I'm recording my own and can just edit it.